Good morning, Doctor. We would like to present about our system, which is parking lot allocation by using next fit and worst fit memory management. Okay, so I would like to introduce my group member, which is Adriana Zulaikha, Tang Jasmine, Min Xue, and me as Melody. Now, I would like to talk about the operating system concept applied in our parking lot allocation. First, in an operating system, memory management plays a crucial role in ensuring that space is allocating to the process efficiently and effectively. There are several strategies used to manage this. And yeah, in our project, we focus on two popular dynamic memory allocation methods, which is next fit and worst fit. For the next fit, this strategy starts searching for a suitable space from the last allocated block, rather than starting from the beginning each time. Whereas the worst fit, this one scanned all available memory and allocated the process to the largest free block. These strategies directly affect how efficiently the system uses available memory, or in our real-world scenario, how efficiently we can allocate parking space to different type of vehicle. Imagine a busy shopping mall parking lot during weekends. There are limited parking slots for various sizes, for example, small, medium, and large, which is designed for different types of vehicles like motorcycle, compact vans, car, and buses. As vehicle enter, the parking system need to decide where to park them efficiently and effectively. For example, a motorcycle shouldn't occupy a large bus spot, whereas a van need to be placed in a large enough space or it must be rejected. If a system simply assigns the first space that fits or the largest one, it might end up wasting valuable largest space on the small vehicle like motorcycle or bicycle, which can lead to the fragmentation and efficient space usage. This is exactly like how an operating system manages memory. It has to allocate space to processes of different size. And the strategy used, like in our project, is next fit and worst fit, affect how much space get wasted. All in all, by applying next fit and worst fit strategy, we can see the impact on space usage and fragmentation by helping parking lot managers, and by analogy, operating system can make smarter decisions in applying the parking lot system.
My name is Min Xue, and I'll be talking about our project design and implementations. We are using HTML and CSS to visualize our project, which is this parking allocation systems. So the algorithm that we are using is JavaScript. As you can see at the right side of this slide, first thing first, we were required to select the vehicles. So there is 5 types of the vehicles, which are bicycle, motorcycle, car, van, and also bus. And next, we will have to select the strategy, whether it's next fit or worst fit. So there is 3 buttons that we can click on. The first one is park to park the vehicles. The second one is to reset the allocations, and the third one is to remove the vehicles. We also include a short descriptions of our parking allocation systems, real life analogies. So think of parking spot like memory blocks. Different vehicles arrive seeking a spot of the right size. We also have short descriptions of about the next fit and also what's fit. So next fit search will start from the last park vehicles. If the space is fit, then we will park the vehicle there. If not, then the searching will continue. So for worst fit is the small vehicles might be parked in the larger spot, thus wasting space for largest vehicles that will arrive later.
In this system, we implement a next fit algorithm where the system search from the last block allocated, then allocate the vehicle to the next block that is large enough to fit the vehicle. And I will further explain later on the implementation.
Now let's move on to the design and implementation of the worst fit strategy. In this system, we treat parking spots like memory blocks. Each vehicle, such as a bicycle, motorcycle, car, van, or bus, requires a block size that matches its length in meters. With, with the worst fit strategy, the system scans all available blocks and chooses the largest free block that is big enough for the vehicle. This method often leads to inefficient use of space as small vehicles may occupy large blocks, leaving gaps that are too small for bigger vehicles later on. On the left, you can see a snippet of the JavaScript code that implements this strategy. It loops through all blocks and checks if they are free and large enough, and then picks the one with the maximum size. On the right is our visual simulation created using HTML, CSS, and JavaScript. Users can select a vehicle and a strategy and then press spark to see how the vehicle is allocated. And lastly, for the real-life analogy, this strategy can lead to a wasted space, just like parking a bicycle in a large parking spot.
My name is Jasmine. So previously, my teammates already briefly explained on the parking lot allocation system. So I'm now going to show the implementation of this simulator. So as we need to visualize how can this parking lot allocation simulator represents the memory blocks allocation, I decided to use HTML and CSS to visualize this system, and also JavaScript to implement the next fit and worst fit algorithm, and also the functions that needed for this system. So this is our code. So as you can see here, we use some simple CSS to kind of decorate our UI. And this section of code is basically our UI. And then next we also use JavaScript and functions to perform the algorithm. And now I'm going to explain the components on this UI. So on the right side, we have this parking lot as the block of available memory. And I also assign fixed size like 5 meter, 10 meter, 7 meter, and 12 meter, so that it can nicely accommodate different size of vehicle to prevent scenarios like small motorcycle occupying the car parking lots, which is not very effective on utilizing the space. So this is also the simulation of the memory allocation, where each block has a limited size. And vehicles are also processed or data that comes in different size. So as you can see here, we have different vehicles with different size. So for example, bicycle with 2 meter, motorcycle 3 meter, car 5 meter, van 7 meter, and bus with 10 meter. So this is just like a simulation to represent the multiple sizes of data that need to be stored into the memory. So first I'm going to demonstrate on the next fit memory allocation. So for example, I will allocate the bicycle with 2 meter of size into this parking lot. So the first parking lot with 5 meter block is large enough to fit this 2 meter bicycle, so it will allocate the bicycle into this parking lot. And as the bicycle is 2 meter in size and the parking lot is 5 meter in size, so it will cause an internal fragmentation of 3 meter. And next I'm going to occupy all the parking lots. So I'm going to park a van and then a bus. So as you can see here, the bus with the 10 meter size is unable to fit in the third block, which is a 7 meter size, because it is not large enough to accommodate this bus size. So it will skip the third block and move on to the fourth block, which is 12 meter in size. So it is able to accommodate this 10 meter bus. And next I'm going to park a car with a 5 meter size, so it's able to fit into this 7 meter block size. So as you can see here, the 7 meter block, which is the third block here, is the last allocated block. So now I'm going to demonstrate on this next fit algorithm. So first I'm going to empty the first, second, and the fourth block. And now I'm going to park a bicycle which is 2 meter in size into this parking lot. So as you can see here, the system allocate the bicycle with 2 meter size into the largest block, which is the 12 meter size parking block, and cause a fragmentation of 10 meter. So why is that so? Because in the next fit algorithm, the system will search from the last block allocated and allocate the next memory to the next block available that is able to fit the memory. So as you can see here, this is our code. So as you can see here, once the last block allocated is true, the index will move on to the next block. So what next fit shows us that as long as there's a space that's big enough to allocate the memory, it will then occupy the memory space. So this also shows the downside of the next fit algorithm, as it is not very effective of the memory usage. As you can see here, I parked the 2-meter size of bicycle and it's allocated to the 12-meter size, which caused an internal fragmentation of 10-meter, which is able to fit another bus size, but it can't fit anymore because the memory block is occupied. Next, I'm going to demonstrate on the worst fit algorithm. So for example, I'm going to park the bicycle with 2-meter. So the system will allocate the bicycle with just 2-meter size into the largest block, which is the 12-meter in size. Why is that so? Because according to the worst fit algorithm, the system will always allocate the memory to the largest available block size. So for example, we can see this code. What the lines do is that the system will always look for the largest block that is not occupied yet. And when it is the largest size available and is not occupied yet, the system will allocate the block into the memory space. So next, for example, I'm going to allocate this motorcycle with 3-meter, but it's going to allocate to the 10-meter block size instead of this 5-meter block size because the 10-meter block size is available, it's not occupied yet, and it is the currently largest block size. So as you can see here, if I want to park a bus, there's no available parking lot that is able to fit in the bus with 10-meter size. So this causes a waste of memory space, and this worst fit algorithm also shows that the ineffective of utilization of the space. So as a summary, this simulation shows us that both next fit and worst fit may lead to fragmentations, which is the unused wasted space. So however, comparing next fit and worst fit, next fit will be faster as it doesn't need to search from the beginning and instead it searches from the last block allocated. And that's all from me. Thank you.
So that's all for our presentation for parking lot allocation using next fit and worst fit memory management. That's all from us. Thank you.